Alright, so today is review. 6, 7, 18. Chapter 8 review, okay? Now, so first of all, in number 1, given triangle PIG, so we want the ratio. So if we want the ratio is just a fraction, okay? So on the very first problem, we're not going to solve the problem, we're just going to set up the fractions. We're going to set up the opposite over the hypotenuse. We're going to set up the adjacent over hypotenuse. We're going to set up the opposite over the adjacent, okay? So we want from angle P and angle G, okay? So we're going to go ahead and start with angle P. Okay, so angle P, let's do the sine of P. We're going to want to do the cosine of P. And we're going to want to do the tangent of P. So we're looking for a ratio, which is a fraction, okay? So the sine of P, let's see, if this is angle P, sine is opposite over hypotenuse. It's just going to be 8/17. That's the answer I want. That's all I want. I don't want you to solve it, I just want the ratio, okay? Cosine of P is the adjacent over the hypotenuse, so it's just going to be 15/17. That's all I want. I don't want you to solve it, I just want you to set up the fraction. Tangent of P, tangent is opposite over adjacent, so all I want is 8/15. There's 3 easy points for you tomorrow, right? Different triangle, same question, okay? God bless you. So we also want to do for angle G. So if I go to angle G, I want to do the sine of G, the cosine of G, and the tangent of G. All right? Angle G, things change around because now the 15 is the opposite and the 8 is the adjacent. So sine G is going to be 15/17. Cosine is the adjacent over the hypotenuse, which is 8/17. And the tangent of G is going to be opposite adjacent, which is 15/8. That's all you have to do tomorrow. Okay? Just set up the fractions. There's 6 easy problems. As long as you can figure out. Yeah, isn't that easy? Okay? First 6 problems, you're just like this, just a different triangle. Just set up the ratios and you're good to go. Yeah, Josiah? You'll have a total of 25 points, right?
Oh, so normal.
Yeah, normal. Yeah. Okay.
You'll leave that thing up there.
Yes, I will. Okay, number 2. So, in number 2, we're going to have to do some solving. So, number 2, Luke, boys. Shh. So, first of all, find the following. So, we go over to our chart. We know an acute angle, don't we? So let's use these rules, okay? Step 1, pick a known angle. Well, I'm going to pick the 50, right?
But you can find.
I could find, you're totally right, okay? Step 2, use the given side.
Side, which is 12.
Step 3,
Choose the side.
so I can either find little t or little a. It does not matter. So yes?
Isn't this a Pythagorean Triple, though?
No, I don't, no. No. Mm-mm. No, it's not.
6 and 8 would be 6 and 6 and 10.
Right, right, yeah. Okay, so, Celeste, what do you want to solve? Little for side A or side T? Which one do you want to side? A it is. It does not matter which one you pick, right? So what Celeste has done, though, is forced us to use cosine instead of sine, which is okay. So what we have is the hypotenuse, right? We want to find the adjacent, so it has to be cosine. So we're going to go cosine of 50, because it's up there, cosine of theta, is equal to my adjacent, which is my A, over my hypotenuse, which is 12, right?
You bring 12 over and go 12.
Yep. Multiply the 12 up. Am I going slowly enough? 12 goes there. 12 times the cosine of 50 equals A, and I'm just going to use a calculator to get that answer, right? So, get a calculator out. And what'd you get, 7.7?
7.713.
How about 7.7 then? Little a then is approximately 7.7?
Yeah, 7.7.
Perfect, okay? All right, there we go. Now, always nearest 10th. Always nearest 10th. Okay, now, what's our next step say? It says find the other acute angle. That's easy, right? 90 degrees minus your angle. So I'm going to go, all right, to find angle A. Angle A is going to be, yep, 90 minus 50. Angle A is going to be 40 degrees, okay? No, it's easy. Yeah, I can do that in my head, exactly. The last step says use Pythagorean Theorem. Now you could use sine to get little t, or you could just use the Pythagorean Theorem. It doesn't really matter. I think sine's easier. Do you mind if I use sine? Okay, if I use sine, yeah, I'm going to go opposite over hypotenuse, so I'm going to use the sine. Why not? So I'm going to go sine of 50 is equal to my t over 12, right? Yeah. You guys are going to get the point where you're, yeah, 12 times the sine of 50 equals t. So you can use Pythagoras Theorem. Hopefully you're going to agree with me that using sine is easier than use the Pythagoras Theorem. So just going to use my calculator. What'd you guys get? 9.2? 9.2? Okay. T is approximately equal to 9.2. So we want to go to the nearest tenth. Awesome. Okay. Thumbs up on that one. Can you do a problem like this tomorrow?
Yeah.
Okay. Okay. All right. Number 3. Given triangle BEN, triangle BEN. Okay.
Yeah.
So if we take a look at my notes, look at my notes. Luke, will you go outside, please? Thank you. Just go. Just go. Go outside. Thank you. So if I take a look at it, I don't know either acute angle, right?
Don't know.
So I have to use this one, okay? So step 1, choose an angle. Which angle am I going to use to solve? Okay, N it is. Okay. Okay, so choose N. That's my opposite. That's my adjacent, right? So I'm going to use tangent. But I'm going to go tangent of angle N is equal to the 3 over the 10. Now the dilemma is we are going to have to use this inverse because we want to find the angle, right? So we're going to go tan inverse. We're going to go tan inverse of 3 over 10. So I'm going to go ahead and just use my calculator quick. Did you guys get already? Probably. Tan inverse tan of 3 divided by 10. I get an answer for about 16.7 degrees.
Okay, so I did get
Wait,
it right.
why do we know that it's negative 10?
Great question. I'm going to answer that in just a second. Okay. So, anytime. Okay, Ben, listen. If you want to find the angle, you always push that button. Always. If you want to find the angle, you always push that button, okay? So if you, and we've said this several times, so I don't mind repeating it, the angle button is the inverse. It's the blue button. Sine inverse, cosine inverse, tangent inverse. Those are the buttons you push when you want to find an angle, okay? All right. Okay, now, if I know this is 16.7, then angle B is pretty easy, right? I can go 90 for angle B. We're just going to go 90 minus my 16.7, right? 90 minus 16.7. Yeah, so angle B is 73.3 degrees. And then to find the other side, which is little e, that's little e, you can use just Pythagoras Theorem, right? Or you could use sine or cosine, right? Okay. So what I can do is Pythagoras Theorem. I can go 3 squared plus 10 squared equals a little e squared, right? Just using Pythagoras Theorem. I've got a 9 plus 100 equals little e squared. I've got 109, 109, but equals e squared, but I'll have to take the square root of that. Sounds about right. Square root of 109 is about 10.44. There you go. 10.44. 10.4 because I round to the nearest tenth. Nice job. Okay. Thumbs up on that one? Okay.
Yes.
Okay. 1 thumb up, 2 thumbs up be awesome, but 1 thumb up is okay, okay? All right? Good. Now, number 4. These are my special triangles. Okay, 4, 5, and 6 are my special triangles. We don't need to use trigonometry. We can just use these. Okay, we can use these. That's exactly right, Ben. So if I No, it's one of these special ones. In fact, right there, write that down, special triangle. So you know, when you see that, you know it's either one of these two, okay? So here it is. 8, 8, 8 squared is 2, right? It's that easy, right? 8, 8, 8 squared is 2 because it's a 45, 45. So it's just 8 squared to 2. Did not take any, but I'm going to want the squared to 2. I'm going to want the exact answer, okay? I do not want a decimal answer. I want the exact answer, okay? Number 5, again, is this one right here, except for it's just sideways. So here's my 20. That's twice, here's my 20. That's twice as big as this side. So that side's got to be 10, right? That's 20, that's 10, and then this is going to be 10 squared to 3. So 20, 10, so I'm just going to put those in there, okay? So we've got 20, this is x is 10, and this is 10 squared to 3. Okay, isn't that easy? Okay, you confused? I don't want you to be confused, okay? So what I have is this triangle here has been just kind of knocked down, okay? So let me draw it below it, Seth. So if I do it like this, so I'm going to redraw that triangle. I'm going to draw it here, okay? X, 2x, x squared to 3, okay? So with the 2x and the x, twice as big. So if this is 20, if that's 20, that has to be 10. Because it's twice as big, okay? And whatever this is, it's that times the square root of 3. So I get 20, 10, and then 10 squared to 3. There you go. Does that help? Okay. All right. Now, 6 is a little bit harder, a little bit trickier. It's trickier because it is this triangle, but right where you've got this x squared to 3, you have an 18. It doesn't say 18 squared to 3, it says 18. We want to solve for x. So we want this. So what we're going to do is say that 18 is really equal to our x squared to 3, and we want to solve for x, okay? So if we can find x, we've got that side, okay? So we need to solve for x. All right, I'm going to do that. I'll go ahead and divide by the square root of 3, divide by the square root of 3. Okay, now, 3 goes into 18 6 times, so the answer is going to be 6 squared to 3 is equal to x. Okay, so that means this bottom part right here is going to be 6 squared to 3.
Wait, how'd you do that so fast?
3 divides into 18 6 times, and it's still square root of 3.
Divide by the number, and then you just ignore whatever happens. And you just leave it there.
Now, you guys learned how to do this, and I'll do it real quick. We learned how to do this last quarter. I'll go back through it, but I don't know if everybody learned it. Multiply by the square root of 3, square root of 3. Remember how we did this a long time ago? 18 square root of 3 over the square root of 9, which is 18 square root of 3 over 3. 18 divided by 3 is 6. Okay, but it's easier just to say I'm going to divide and make it a square root of 3. Okay, that's easier. But that's why it works. Okay, that is why it works. Okay, all right. Now, this side right here is twice as long. So if this is 6 squared to 3, this is 12 squared to 3 because it's twice as long. Okay, this one's twice as long as that. So if this is 6 squared to 3, that's 12 squared to 3. Okay.
Wait, no, not yet.
Okay, number 7. I need a little piece of graph paper, but I'll wait for you. Okay. Okay. Number 7.
Nope.
Okay, let's go ahead and graph this.
Well, you got like real graph paper.
Well, it's not really. It's not very good graph paper, but it's going to work.
It looks
4, 1, 2, 3, 4, 1, 2, 3. There's R. S is negative 2, 3. S. Negative 2. Negative 5, 1, 2, 3, 4, 5. Okay. Okay, I do have a right triangle. Let me go ahead and draw that in. Okay. Okay, there you go. Draw my right triangle in. There it is. I might even highlight it so it's easier to see on this graph paper. So, do you need some more graph paper?
Rulers.
They're right here. Okay. So, here's my triangle, right? And I want to find angle R, and I want to find TR. So first of all, just looking at it, seems like I don't know anything, but I do. I know some very important things. I know that this is 90. You guys agree with that? I know that's 90. I also know the lengths. This is, if I count 1, 2, 3, 4, 5, 6. I know this side is 6. 1, 2, 3, 4, 5, 6, 7, 8. Here's your Pythagorean triple, Cody. But I'll get there. I will. I'll slow down. But this one's definitely Pythagorean triple. Because, Cody, it's a 3, 3, 4, 5 or a 6, 8, 10, right? Right. Okay. Now I will slow down for you, Ben. Okay. Now I do know. I just can count. I know enough information. So let's go over here. I do not know. I don't know an acute angle, right? So let's use these directions. Okay. So choose an angle solve for it. Well, I have to find angle R, right? Okay. Step 2. Use the two given sides. So what I know my 6 and my 8, which happens to be my opposite and my adjacent. Okay. Ben, I'm going to review with you because you asked a really good question. You said, why do you use that inverse butt? Okay. So I want to find an angle now, don't I? Right? Am I going too fast?
Yes. Yeah.
I'll wait for you. I'll wait for you. Okay. I'm happy to wait for you.
You started from P, right?
It is going to be tan, yes. Tan inverse though, right? So if I want tan of R is going to equal 8 over 6, right? Okay, because it is opposite of adjacent. But if we want to find the angle, we must use the inverse button, okay? So what I'm going to do is really tan inverse of 8 over 6, and I'll show you how that goes in your calculator, okay? So my calculator, we're just going to go second tan. So you got to use that tan inverse. I got to hit the blue button. You have to use the blue button to get this blue tan inverse, okay? Hi Emily, hi Lolo. Of 8 divided by 6. Boom. Okay, I got about a 53.1 degree angle. You guys want me to sign? Come on over. Well, you know, this is going to take me a second, right? Okay. And I did get your uniform.
You got one.
I know. Yay, and I'll see you guys this afternoon.
Yay.
Practice. Cool.
Thank you.
Nice job, girls. Bye.
Thanks.
Okay. All right. Ben, did that help get you caught up?
And if we find an angle between minus it by 90.
Okay, right. And we don't need that, but you're totally right, Michael. Totally right, okay? We don't need the other angle. All we need is angle R, which we have, and then we need this length TR. So if we use Pythagorean Theorem, right, we can get that. So I can go, okay. Okay, so are you caught up with me? Did you get angle R? And angle R is going to be about a 53.1 degrees. Now, to find RT, I'm just going to use Pythagoras Theorem, right? So I'm just going to go, all right, I'm going to go 8 squared plus 6 squared equals C squared, right? A squared plus B squared equals C squared.
So it's 10.
Yeah. Yep. You guys are all right. It is 10. It's totally 10. Yep. And so 100 equals C squared, squared. So the guys back here talking about a Pythagorean triple. The word Pythagorean triple is a word. You don't have to know this, but it's a word that says if all three numbers are perfect whole numbers, like 6, 8, 10, no decimals, that's a Pythagorean triple. The Pythagorean triple is where all three numbers are nice whole numbers. This is a Pythagorean triple, yeah.
Does it work better with?
It's just nicer numbers. You don't have ugly decimals. Yeah. There's only so many of them. There aren't a lot of them. Okay, should we turn the page and do some story problems? Okay, now, story problems aren't necessarily hard if we just draw a right triangle, okay? So draw a picture, okay? So number 8. So an 18-foot ladder leans against a 12-foot wall, okay? So here's my wall. Here's my ladder.
Oh.
Right?
They never said it was perfectly matching up the house.
We're going to assume the wall is straight. So we need the angle.
Who would put a ladder like that?
I don't know.
Well, you can walk on it.
It could be a little dangerous. Could be, yeah. Yeah, there you go. So, what do you think? We need to find the angle, right?
Flip it the other way. Go like that.
So, opposite hypotenuse, right? Let's use opposite hypotenuse. Let's use the sine. So sine of theta is equal to the opposite, which is 12, over the hypotenuse, which is 18. And I just need to use the inverse button, right? I need to go sine inverse of 12 over 18. Use my calculator. I'm going to go sine inverse of 12 divided by 18. And we get about a 41.8 degrees. Okay? That's your angle. That's all I have to find, right? You're done with that problem. You don't have to find anything else, just the angle, okay? How am I doing?
Good.
Okay, you guys are doing a great job paying attention, not talking. Number 9, the shadow of a tree. Now remember, shadows are on the ground. I know a lot of kids get this wrong because they think shadows are cast, but that's not the shadow. Shadows are on the ground, right? Shadow of a tree on the ground is 18 feet long. So here's my tree. Okay, here's my tree. Here's my tree.
That's a beautiful tree.
Here's my tree. Here's a shadow of 18 feet, right? And the angle of elevation to the tree is 54 degrees, okay? What is the height of the tree? Okay? So we do know an angle, right? We do know an angle. So opposite, adjacent, right? Let's use tangent. Tangent, opposite adjacent, tangent of my angle, which is 54, is equal to my opposite, which is h, over 18. Okay? And we're just going to multiply by the 18. Bring it up, multiply by the 18 times
Slow
it.
down, like a lot.
Yeah, sure. Happy to slow down. Okay, yeah, Bijou?
So when do we, this is kind of like,
No, there's no such thing as a bad question.
when do we, other than knowing what sides we have, when do we know, out of sine and tan, when do we know which one to use?
Great question. Great question. What two sides am I working with? I'm working with this side and this side, right? I don't know anything about this, so I can't use this, right? So from the angle, the name of that side is the opposite, right? And the name of this side is the adjacent. I don't know anything about the hypotenuse. So I look up there and say, okay, which one of those three works with the opposite and the adjacent? So look up there. There's only one of them that does the opposite adjacent up there. Which one is it? Opposite adjacent. It's 10. Does it, see how that works? So that's how you can tell. You look at your two sides that you're going to work with, and you look up there and say, which one am I going to use? That helped. So see, Seth just went, oh, so it's actually a very good question. So same thing here. Look at this. Opposite hypotenuse, right? So Bijou, if I look up there, there's only one of them that uses opposite hypotenuse. Which one is it? So does that help answer your question? There you go. Seth, appreciate your question, don't you? Yep. Okay, so use my calculator. 18 times tangent of 54. Yeah, or 24.8, right? Feet. Because we're going to round in the nearest 10th tomorrow, all the way through. We're going to round in the nearest 10th, okay? Thumbs up so far? Okay. Okay, good. Number 10. So wheelchair. You've got to be a little careful on this tomorrow. Feet and inches, okay? Let me highlight that. Feet and inches. You've got to be careful. Because when you build a wheelchair ramp, you've got to keep it pretty low so Granny can get up the ramp, right? So when they built this ramp, you've got a height of 4 inches, and you've got the ramp. Now the ramp, this is not the ramp. Granny's not going up this. This is the ramp, right? Now this is, if this is in inches, then this would be 48 inches, because I know that 4 feet is the same thing as 48 inches, right? I need the angle. Because if the angle's too steep, we've got to tear it down and rebuild the ramp, because Granny's got to be able to fit, okay? So, Bijou, you ready? This will help you, okay? Here's my angle. What is the name of this side? Here's my angle. That's my opposite. What's the name of this side? Good. So if you look up there between those three, which one of them uses those two words? Good. You're getting it, aren't you? So we're going to go sine of my angle equals opposite, because it does say opposite on top of the fraction, opposite on the top of the fraction over 48, because my fraction says up there it says the opposite over the hypotenuse, right? So I've got the 4 over 48. Now, Ben, what button must I push to get the angle?
Negative sign.
Yeah, so we're going to go sine inverse of 4 over 48 is going to give me my angle, right? So I just use my calculator. We're going to go clear. We're going to go second sine of 4 divided by 48. And you get about 4.8 degrees. Now, that's a pretty small angle. By code, that would work. So if you have an angle bigger than 8 degrees, they won't build it because granny can't get up it, okay? All right, we're almost done. So 11, we've got an airplane flying at an elevation of 8,000 feet. And it starts to descend towards an airport with an angle of depression of 8 degrees. Okay, so how far is the airplane from the airport? Okay, so let's go ahead and draw this. Here's my little airplane. Here's my airplane. Here's my tower way down here, right? Airplane's descending, right? Has a height of 8,000 feet. Okay. Angle of depression. So my angle of depression is 8 degrees because that's the angle going down. I don't really want to use this triangle. I want to use the triangle below it. So this 8 degrees is also 8 degrees here. Those two angles are equal. So I'm going to use the triangle below it though. So let's see. What do we want to find? How far is the airplane from the airport? Okay, so I need to find this distance here. We'll call it x, okay? Because airplane's from here to here, right? So I need to find that distance. How far is the airplane from the airport? So let's go through it. Here's my angle, right? I know my opposite. I want to find my hypotenuse. So yeah, so the two words I have are opposite and hypotenuse. I look up on the top. Which one of those uses those two words? It's got to be sine. So I'm going to go sine of 8 degrees because that's my theta. My angle means, theta means angle, is equal to my opposite, which is 8,000 divided by my hypotenuse. Now, since the x is on the bottom, we're going to end up dividing. We're going to end up dividing because the x is on the bottom, okay? So if I divide, then we'll multiply the x up here, bring up the x, and I'll have x times the sine of 8 equals 8,000, okay? And I'm solving for x, right? So then I have to divide by sine of 8, divide by sine of 8, divide by sine of 8, and I'm just going to use my calculator, okay? 8,000 divided by sine of 8, and I get a pretty big number, but it should be, because we're a long ways from the airport, 57,482 feet. And of course, if you want to change that to miles, you just divide it by 5,280, because they would probably do it in miles. But I'll take obviously the feet, okay? If you divide it by 5,280, yeah, we're about 11 miles out.
Wait, what are
Yeah,
you
about
dividing
11
by?
miles.
Huh?
Nice.
What are you dividing by?
5,280, and that's how many feet are in miles. But wait, you do not have to do this, Bijou. I would take this. Is the answer. This answer is fine. Yeah, it's kind of neat because you wouldn't really measure that distance in terms of feet. I mean, the pilot would say we're 11 miles from home, right? The pilot wouldn't come out and say we're 57,000 feet away from home. He was like, what? We're 57,000 feet away from home? What is he talking about? 11 miles, right? Actually, it's 10.88. Okay.
Well, I didn't expect my,
Now,
Hold on.
yeah. Now, that answer is fine with me. Okay. I divided. What I did is I divided by. 5,280 because that's how many feet are in 1 mile. Does that make sense? Yeah. Hey guys. Okay, finally. There you go. Yeah, if I knew I'd get it. Otherwise, you weren't going to graduate, right?
Yeah, right. I kind of need to do that.
Yeah,
so
pretty much. Okay.
that'd be the fastest.
Thank you.
All right.
Okay.
And then
It's on.